Okay, folks, so this is your video, kind of your cleanup notes for the next section. You didn't watch videos on it. If you want some additional examples beyond this, feel free to go log in and check the resources out for section 2.4 um, on the Connect Ed website. There's some videos there you can watch if these don't explain what we're talking about thoroughly enough for you. As we go through yesterday, we looked at problems involving solving equations where there was a variable only on one side of the equation. That process is still in place. So as we go through, we're still going to do those processes for the problem. But before we do a couple things, we want to make sure we take apart each side first. So as we look at an equation that has variables on both sides, we want to first treat each side of the equation as its own expression. So look at the left side, look at the right side, and go through and simplify those as much as possible. So as you're going through, we want to make sure we first apply your distributing property. So if you have parentheses with something being multiplied, distribute that in. And then after that, combine any like terms. So we're going to clean up each side by itself first. It's going to give us less numbers to work with. It's going to give us less problems in the long run. Once you simplify it, we're going to then go clear our fractions. We talked about that yesterday. We're going to get rid of those fractions so we don't have to deal with them anymore. We'll see an example of this here in a second. And then we want to move variables to one side and non-variables to others. Those are our constants, our numbers. Okay, so your letters are going to one side, your non-letters are going to the other. And again, we move things by adding and subtracting. Remember, use inverse operations. So we'll add that in here. So we're going to use the inverse operations. When you add the inverse operation is subtract. When you subtract, the inverse operation is addition. So make sure we're using inverse operations in there. And then finally, isolate the variable. If you clear fractions, your isolation will be done by dividing, because you'll have something times x or whatever variable you're using, and then go from there. So those are your basic ideas. Make sure you add these into your notes so you have that to follow as you go through the problems. It's a good checklist to go through and take care of. All right, so let's jump right into the examples. Start here for this first one. We'll start real basic and we'll build our way up. All right, so we're solving for x, that's a given. And what we're looking at, we look for those things first on both sides. If I look on the left side, 3x minus 7, or plus 7, excuse me, I don't have parentheses, so I don't have to worry about distributive property. In like terms, I have a 3x and a 7. These are not like terms, so I do not combine them. That would be incorrect. I don't have any fractions to deal with, so don't worry about that. Over here on the right side, same idea. There's no distributive property, and 5x minus 11 are not like terms. Now, one thing you have to be careful, if I look, 3x and 5x are like terms, but they have this big wall in the middle. You can almost treat the equation like the equal sign is a big wall. They're like terms, the 7 and the negative 11 are like terms, but I have to get them on the same side before I get things where I want it to go. So I'm going to start that. We said start by moving the variables to one side. Now you have options here. It doesn't matter which way you go as you do this. You have 3x over here and 5x over here. You could move the 5 over here or the 3 over here. In this case, I'm going to move the 3 over to the right because when I subtract 3, because it's a positive 3x, I'll have a positive result on the other side. So I go ahead and I subtract 3 from both sides. 3x minus 3x, those cancel out for me. Bring down the 7 equals time. 5x minus 3x is 2x. Just do the subtraction. And I didn't bring down 11 yet, so bring that down. Okay, I've moved my variables to the right. That means I'm going to move my non-variables to the left. So here's my non-variable that needs to move over here. So I'm going to do minus 11. I'm going to add 11 to both sides. I'm going to add 11 to both sides. Okay, again, those cancel them out over here. We bring down the variable. It hasn't been changed yet, so that's still 2x equals 7 and 11, you get 18. Got to that point. No fractions to work with, nothing to worry about there. I can simply divide by 2 because that is the inverse operation. That gives that 1 there we're looking for. I have a single x, and that's equal to 9. So 9 is my answer. How do I know it's true? Well, I can go back to my original equation and check it. We did this in the warm-up yesterday. We plug the value in, I should get the same on both sides. So is 3 times 9 plus 7, is that the same thing? This is our check, as 5 times 9 minus 11. Well, let's go through and find out. All right, 3 times 9, that's 27, plus 7, that's 34. Okay, cool. We want to know, is that equal the same thing? Well, 5 times 9 is 45, minus 11, we get 34. Yep, that's true. So I know that I have a correct answer, that x is equal to 9. Our check is a great way to work with that. Okay, let's up the ante a little bit. Let's now throw some fractions in there. Okay, so again, I have distributive property. I'm sorry, I don't have distributive property, but I have a bunch of stuff floating around with all these fractions. So I don't have distributive property to worry about. These are like terms, but they're kind of not in the same form. So let's go through and clear our fractions first. We talked about this yesterday, is what we look at is the denominators. I have 2, 2, 4, and 3. And so we ask ourselves, what is the least common denominator? What's the smallest number that can be divided by 2, can be divided by 4, and divided by 3? Your answer there is 12. So I'm going to multiply everything through there by 12 to clear out my fractions. Okay, so everything, not just the fractions, every part of this problem gets multiplied by 12. Don't forget the 7. That's going to be the one people are going to forget. So if I do the multiplication, again, multiply and divide. So 12 times 3 is 36. Divided by 2, you get 18. X minus 7 times 12 is 84. Plus 1 times 2 is 12. Divided by 2 is 6. Equals 1 times 12 is 12. Divided by 4 is 3. With your x, plus 2 times 12 is 24. Divided by 3 is, 8. I almost put 4 down. Okay, so we look at that. We look for like terms. I have like terms here. So I'm going to combine those. So negative 84 and positive 6 is a negative 78. Oops, forget my x there. Will equal 3x plus 8. Now it's just like the previous problem. Move variables to one side, move constants to the other side, and we can be done with this. So I'm going to move 3x to the left this time because I want a positive value. This makes life easier. That gives me a 15x. Bring down the negative 78. Bring down the 8. And continue on. So I'm going to add 78 because that's the inverse operation of subtraction. Because those will cancel those out for me. That's what I want. Bring down the 15x because that one didn't change. So equal 86. Cool. Go ahead, divide by 15 because that's the inverse operation of multiplication. All right. As I look at that 86 over 15, they don't have any common factors. So that's going to just be my final answer, 86 over 15. And that's going to be your problem done right there. Okay. So again, review really quick. I cleared my fraction out, multiplied through it. 12 times 3 is 36, divided by 2 is 18. 7 times 12 is 84. Half of 12 is 6. A quarter of 12 is 3. 2/3 of 12 is 8. So we just went through and moved everything around, and it came out nice for us. All right, so finally, one final example here to go with this. Okay, no fractions, but a bunch of distributive property and like terms we have to combine. So let's jump right to it. All right, treat each side separately, folks. Work with them so you're not working at too much at a time. So let's distribute the 3 in. So 3 times 2x, you get 6x. 3 times negative 1 is negative 3, and then plus 7. Be careful of your addition. It's a negative 3 and a positive 7. Not 3 plus 7, it's negative 3 plus 7. Those are my like terms. That gives me a positive 4. Okay, so the left side, taken care of as much as possible. Right now, we distribute that negative 4 in. So the 5's here. Negative 4 times x is negative 4x. Negative 4 times negative 3, watch your signs, is a positive 12. And I have plus 2x. Well, in this case, I have a couple sets of like terms. I have x's and I have numbers. Start with x's. negative 4 and positive 2 is a negative 2x, and 5 and 12 give you 17. Now, something you're going to look at and you're going to want to do, but it would be wrong. You see 5 minus and then a 12. Remember, the minus is with the 4x. So it's a positive 5 and a positive 12. Give you a positive 17. Okay. So I'm down to that point, no fractions. I can just move things over. Okay. Looking at this, where is it going to give me a positive x value? Well, if I subtract 6, I'll have negatives. But if I add 2x to both sides, I will have what I want. Those will cancel out. I'll have 8x plus 4 equals 17. Now I have variables on the left, so I move my constants to the right. I have plus 4, so do the opposite of that, minus 4, minus 4. You get 8x equals 13. Okay. Divide by 8, divide by 8. And again, I can't simplify that, so my answer, 13 over 8. And that's your final answer for the problem. All right, so again, I went through, distributed my problem, did my numbers in, got to that point, distributed over here, combined all my like terms, okay. Move my variables to one side of the equation, the left side in this case, move my non-variables, my constants, to the right side of the equation, and then to finish things off, I divided. So that's the general idea. All we've done is added an extra layer to things that we had before. We went through, we cleared stuff out, we simplified it, we moved stuff around, and then we isolated our variable. And in the end, we got our answer. So that's the addition in section 2.4. There's still the property of equality there. Make sure it's used wisely. And that will be the end of this lesson. So you'll have time to work now. I hope you enjoy it. See you on Monday when I get back.